morning everybody and welcome again to our course on Introduction to Mechanical Micromachining. In the last class we have started a discussion on spindle and we have seen that there are two different type of spindles. One is the belt driven spindle and another is the integral motor type spindle. And we discussed about what are the advantages and disadvantages of belt drive spindle. And we observed that it is very difficult to get a very high RPM because it is a one type of mechanical movement transfer from motor to the other spindle by belt or gear drive. And we have seen that there are different type of slippage happens or there is a high tension, so that you may get a different type of radial loading and that is not good for high speed spindle. So, there are some options like a integral motor spindle where we can mount the motor itself into the spindle. So, you do not require any type of belt drive or any other motion transmission element. So, let us continue our discussion on integral motor type spindles. So, this was the last slide where we have seen some of the disadvantages of the belt driven spindle. So, now coming to the spindle with the integral motor. So, these are some of the spindles where spindle motor and whatever things you require for movement of the spindle shaft, everything is integrated in a single body. So, you do not require any belt drive or any other mechanism by which you can transfer the motion. So, integral motor spindle does not rely upon the external motor to provide the torque and power. So, you just require one power socket here, so that motor is inbuilt. Even if you are adding some encoder like a rotary encoder, that is also inbuilt within the system. So, everything is very compact and you can easily mount at a small location in the machine tool. So, motor is an integral part of the spindle shaft and housing assembly. So, what is the problem here, that you have to prepare a housing for this particular motor spindle, because if you have seen that belt drive spindle, at that time what was that belt motor was located at a different location. So, your housing was not connected with the motor. But when you are using a integral motor spindle, at that time you have to also think that you do not have any provision to change the motor or anything, that we have seen in some of the advantages of the belt drive spindle, but that advantages are not available for integral motor, because it is a single body and whatever specification is there, you cannot actually change the specification by changing any of the components, because all components are designed with respect to the full body. It allows the spindle to rotate at high speed as a complete unit without additional limitation of the belt and gear. So, that is the one of the advantages which is we are extracting out of this integral motor, so that our requirement of a very high speed is fulfilled by the integral motor spindle. So, what are the different components? So, this is one of the general view of the integral motor spindle. So, it comprises of the spindle shaft. So, now this is the spindle shaft, whatever we are looking at this part. So, this is the spindle shaft and that will continue till you are getting the motor, that means electrical power supply, including motor elements and tooling system. So, here we are attaching tooling here at this location. Right. The spindle shaft is held in position by a set of high precision bearings. Now, it is up to us that how many bearings we want to use, because number of bearings will increase the stiffness of that, because if you are putting instead of a single bearing, you can put more than one bearing also, so that you can get a more stiffness in terms of the radial loading and the axial loading. But minimum requirements is that you have to put bearings at the front part as well as the rear part, because the bearing whatever shaft you are talking here right now, it will undergo in a two different type of loading. One is the radial loading and another is the thrust loading, that is along the axis of the shaft. So, you have to choose the precision bearing, because we will see in the next few slides that there are different type of bearings available. Ceramic bearing is the one of the latest thing which mostly people are using in the high speed bearings. But other than ceramic bearing, we have a angular contact bearing, cylindrical roller bearing are also available. So, those things are there. Then this is the front end of this part. Drawbar is used to actually remove and add couple your cutting tool here at this location, because drawbar has a one type of plunging mechanism. By that plunging mechanism, when it is moving outward, at that time it will open the jaw of this particular assembly whatever you are using here, and when it is drawing back, at that time it will actually grip whatever things you are adding. Mostly it is a cutting tool. And rotor is available here, then drawbar spring is available, because once you retake it, that the time spring will again come back into its original shape. Encoder is used because you want to also measure what is the RPM at which this particular spindle is rotating. So, this is the rear housing, stator and motor, everything is inbuilt in this thing, because we are considering as a integral motor spindle. So, these are the different type of components of integral motor spindle. So, bearing require lubrication methods such as grease and oil. So, many times whatever it is a permanent lubrication. So, if you put grease, at that time you do not require a frequent use of the lubrication, but for this particular type of system where you are using a angular contact ball bearing or cylindrical roller bearing, at that time you have to apply oil. So, for applying oil, what you have to do, that you have to provide some spacing here or some type of what we can say, that some type of passage through which you can actually put the oil continuously or the intermittently. So, there are different mechanisms, we will see those some of those things in the one of the animation, by which you can understand that which way we can provide the lubrication. Other than lubrication, cooling is also required, because even though we are using ball bearing and the roller bearing, there is still physical contact, either it is a point contact or it is a line contact. So, at the end you need a cooling also. So, it is more, sometimes it is air cooling. So, it will provide one type of air supply throughout the components, other is the water cooling. So, there are you can provide a different type of opening here, slots and something where the water will pass through it, and then it will cool the most of the components. So, this is the integral motor spindle. Now, coming to the housing. So, what is the housing? The housing is the things where you are putting this integral motor spindle into it. So, it may be integral part of the machine tool or may be a block, foot mounted or flange mounted cartridge housing. So, now this is what we are talking is a housing. So, this is actually the one of the block mounted. So, here what is the thing, that your spindle is actually completely packed inside it, and this is the whole block, or you can say housing of that. So, it will actually retain the spindle at a one particular location, or it will not allow any type of movement. So, if you want to fix this particular thing, then what you can do, that you can actually change this particular integral spindle and without changing this part. Sometimes it is an integral part of the machine tool. So, if you know that which particular spindle you want to use, then what you can do, that you can put this thing as an integral part. So, you do not require any type of additional assembly here, and once you reduce the assembly, at that time we know that wherever there is assembly or wherever number of many parts are there, chances are high that it will be loosened at the later stage. So, it is better to make a monolithic structure, so that you can reduce the number of joints, and at the end it will increase the stiffness of the machine tool also. So, it is sometimes it is like that, or sometimes you put the block or flange mounted cartridge housing type of thing. And this is the another thing. So, that is called cartridge type housing. So, this is cartridge. So, here things is that this is a block type and this is the cylindrical cartridge type. So, there are some advantages associated with this particular cartridge type housing. So, there is a simple to service here, because here what is going to happen, that you first thing that you have to prepare a block, and then you have to create a dimension as per the size of this particular spindle. But here whatever the both the things are cylindrical parts. So, it is easy to actually make the cylinder compared to box, because you have to turn only, and whatever dimensions or the tolerances you are need for this particular thing, everything will be achieved in a much greater way as well as much easiest way. So, tolerances required for high speed are easier to obtain when housing can be provided as a cylinder. So, in the cylinder you can actually create a very fine surfaces, and whatever things you want to want this for this particular housing, you can easily get this thing done in the cartridge type housing. So, there are some advantages associated with this thing. So, mostly people go with the cartridge type housing compared to this particular part. But here you what is it is mostly for the heavy duty operations, but it is not considered for the micro machining operation. Now, coming to the bearing. because we have seen in the 1 or 2 slides before, the bearings are playing very important role compared to other components, because wherever you want to transfer motion from one body to another body without much friction, then bearing is very important, that it may not make any problems during the transmission or the power losses. So, one of the most critical component of any high speed spindle design. So, what are the things we need from the bearing? So, it should provide a very high rotational speed, because that is we required, because our diameter of the tool is very small and we have to maintain the productivity. And transfer the torque, because torque is also important when you are drilling in a very high depth, and if you do not have sufficient torque, then your particular motor will be jammed and you are not able to rotate the spindle at a reasonable speed. And power to cut the cutting tool, because when you are talking high power means you are mostly talking about the high power torque only. Low power motor has low torque, but it has a high rotational speed. So, those are the things, and be capable of reasonable loading and the complete life, because if you change any of this parameter, what is going to happen, that your life will be in sacrifice, because you are not maintaining something within the specified limit of the allowable part. So, here you have to also consider what is the loading, because if your spindle is designed for a soft material, that means it is a high RPM and you can go with a very small amount of depth of cut or small amount of cutting parts. At that time you can actually use this thing very easily, but if you increase the depth of cut beyond a certain limit, what is going to happen, that your tool will actually experience more amount of loading, let it be thrust loading or the radial loading. So, in that case it will exceed the allowable limit of this particular specific bearing, and then there is a failure of the bearing or some type of other problems will occur. So, bearing type must be used must be consistent with the above demands, or the spindle will not perform. So, that is what we have discussed, that whatever we want to get out of this particular spindle, then we have to think about that what are the different type of bearings which will fulfill this requirement with a reasonable amount of allowances, because we know that you cannot fulfill all the, some of them are very contradictory to each other. So, you have to reach to a one compromise position where you are not losing many things, but you are also gaining something which is required for your application. So, what are the selection criteria? So, what is our requirement first? Then we have to select that which one is the bearing we can use, and then we have to see that what is the design impact in the. So, if you see, if you are looking for a high speed, then what you have to go with, you have to go with a small angular contact bearing. And if you are going with this thing, what are the design impact, that you can your shaft will be small and the power will be very low, because when you are going with a high speed, what is going to happen, if the shaft is very large, then there is an inertia effect. So, you have to rotate a very heavy object to a very large high speed, and at that time it will create at the time of acceleration and deceleration. And low power is required, because if the small shaft is small, you do not require very high power, and similar for the high speed. So, this is one of the thing. Now, if your requirement is high stiffness, that means when it is going with going to operate under a some type of aggressive machining, like a depth of cut is very high and material is very hard, at that time you need a high stiffness in that, because you do not need do not require that your bearing or the spindle will actually get loosen, or what we can say that it will deform internally because of these external forces. So, what we have to need, that here we require a large roller. So, large roller will help you to actually take care of all the external loading, and it will not actually deform itself. But if you use a large roller, then again inertia effect will come and centrifugal force effect will come, so that you cannot go with a low high speed. So, your spindle design impact will be low speed and the large shaft. So, it is exactly opposite to this particular part. So, now you can see that stiffness and speed, both the things cannot be matched together. So, obviously, we have to compromise with a one particular location where both the things can be reasonably good within the limit. If you are talking about axial loading, that is mostly in the drilling operation. So, when you do drilling, we know that we are just pushing the drill from top to bottom only, we are not moving in the sides. So, that is called axial loading. So, at that time we have to go with a high contact angle. So, that I will discuss in the few slides, that what is the contact angle, how it will impact the axial loading. At that time when you are talking about axial loading, then the speed will be lower, because when you increase the speed, at that time ball will try to escape in the radial direction, but you do not have the more loading, more stiffness in the radial direction. So, you have to go with the lower speed. Now, it is obviously if it is a radial loading, then lower contact angles are required, and at that time you can go with the higher speed. So, this both the things. So, what is the this particular contact angle will decide that which one is higher, whether it is axial loading or it is a radial loading. So, if it is if you put something in between these two, that is moderate contact angle, then you can get the advantages of both the things, that is the axial loading and the radial loading. High accuracy, that means what is the dimension of this particular, that means the inner bore, outer bore, races, as well as the complete dimension. Then this is one particular standard, that is American Bearing Engineering Committee. So, this particular 9, and these are the symbols I will show you in the next slide. And high preload is required, because if your preloading is not very high, what will happen, that your ball will actually not firmly grip between the inner race and outer race, and that is because of that reason you will not get the higher accuracy. But there are problems also associated with this, because if you are increasing the accuracy at ABEC 9, then they are very expensive, because you have to spend more amount of time in refining the dimension and making it more and more compact or within the tight tolerances. But you cannot go with the high speed, because if your preloading is very high, then you have to sacrifice the speed. So, these are the problems. Now, you can show that many of these things are actually not in the same trend. If that means, if you increase the one thing, other thing you have to decrease. So, compromises must be made in order to arrive at the most efficient design possible. So, you have to find that how you can extract the maximum benefit out of these particular things, and always see that what is your requirement, which bearing you are selecting, and what is going to happen with your design. So, if you are going with a high RPM, then it is you have to go with the radial thing, and you can again go with the other power, that is a high speed this thing. So, by this particular table you can finalize the which type of bearing is more suitable for your application. Now, this is the tolerance standard. So, this is the commonly used standard is the ABEC, America Bearing Engineering Committee, and it is also equivalent to ISO and the DIN standard. So, what it defines, that it defines tolerances for major bearing dimension, that is bore, inner diameter and the width, and the characteristic, that is the bearing geometry. So, what things are there? Though, if you are talking about the ABEC 1, it is mostly a general purpose bearing, because here we are not making very tight tolerances, so that it is it becomes very specific. But if it is a general purpose, then actually what you need interchangeability. Suppose you want to change a bearing which is not operating at a particular level, then you can change it. So, if it is ABEC 1, then it is very easy to get some replacement without any problem. If you go with ABEC 9, that is high precision bearing, suitable for use in high speed spindle. So, what we are looking here, that we know that our requirement is a very high precision requirement, and we have to rotate at also a very high speed. So, in this particular case our target is ABEC 9, but you can see that these are as you go down in terms of number, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, your requirement cannot be general purpose. Then you have to focus on a one particular part only, then means you do not have so much of interchangeability, you have to go with the same bearing which you want to replace with the one. So, how you can actually decide the which one is best for you? Then when you are actually making a spindle bearing, geometric accuracy should be in the ABEC 9, because here what is our requirement? Because we need a very high precision, we want to minimize the run out and rotational accuracy. So, minimizing run out is very important, we have to maintain the rotational accuracy also, because we do not want that it should rotate in a some different other than this concentric rotation. So, this is for making of a geometry of this bearing. But when we are talking about the bore ID and width, at that time it is better to go with a little bit lower side, not onto the higher side, because we have to fit this thing in a one particular dimension. Because if you go with this also ABEC 9, what is going to happen, that your dimensions are extremely tight in this case. So, if dimensions are very stringent controlled, then what is going to happen, the whatever way you are putting, that means when you are putting in housing, at that time housing should have been also machined at this particular ABEC 9. So, it actually increase the more amount of tightness in that. That means you do not have so much of flexibility in terms of fitting and installation. So, it is better to go with a accuracy of a ABEC 9 when you are talking about the spindle bearings and all these things. But other than that, when you are talking about dimensional, that means in geometric point of view, at that time it is better to go with ABEC 7, which will allow you to become a more flexible in terms of fitting and the installation. And these are the equivalent standard of this. The class 4, class 2 are the ISO. This is DIN standard, it is given by P4, P2, and this is what we are discussing right now here. It is ABEC 7 and ABEC 9. Now, these are the two different types of bearings which are routinely used for the high speed spindle, that is angular contact ball bearing and the taper roller bearing. So, what is this angular contact ball bearing? So, this is the commonly used ball bearing, and it is most commonly used for the different applications. They provide precision, load carrying capacity and speed required for the metal cutting spindles. Because why we called it the angular contact bearing? Because this particular contact is at some angle. So, that particular alpha angle is the contact angle. So, we have seen that high contact angle and low contact angle. So, this is that particular angle at which you are putting, that means where is the contact between the ball and the race, is that particular line will tell you this angle. We will see in the next slide that what is more detail about this. Then the taper roller bearing, now we know that it is roller bearing. So, it is a shape is roll type, not the ball type, and it is a taper. So, there is a taper in between these two. So, what is the advantage here? That you will get a high load capacity and a greater stiffness over the ball bearing. Why it is so? Because here what is going to happen, that your contact is at the very small area, but if you see this particular thing, then your contact area is very large here. So, bearing will actually take more load, and that is the reason that it has a high load carrying capacity, and stiffness is also very high, because your size of this particular thing is very large. So, your per unit force will be very less in this case. So, your stiffness is very high compared to the ball bearing. Right. However, tapered roller bearings do not allow the high speed required by many spindle, because here also when you have high contact area, that means there is a high friction and wear also. That here it is a mostly a very small area of contact, but here it is a more area contact. So, it may create a problem at the later stage when you operate this particular bearing beyond a certain speed. So, at that time it will not allow you to operate as compared to the ball bearing. So, many times your speed is limited by the area also, but if you are looking with a high load carrying capacity and high stiffness, you can select this particular bearing. Right. So, this is the angular contact ball bearing. So, here it is designed to provide both axial and the radial load carrying capacity when properly preloaded. So, this is the preloading. I will talk about these things in 1 or 2 slides later. So, where do you need this both the things? Because when you are talking about axial loading, what we are talking about, that this is considered it is a shaft, right, and bearing is located here. So, when you are getting a force here, now you consider your tool is located here. This is the tool, and now consider it is a drill. Let us consider it is a drill, right, and this is your workpiece. And when you are pushing this thing inside, what is going to happen? You will get one force, that is called thrust force, right. So, this is the axial force. Correct. So, this is called axial force. Now, consider that this is mostly for the drilling operation. Now, again consider that you have a shaft, but instead of a drilling you have a milling cutter, right, and this is your job. Correct. So, now you want to create one pocket here. This is the pocket which you want to cut out of it. So, first what thing you are doing, that you are plunging this thing up to the depth. So, when you are plunging, at that time it will create a axial loading. Correct. and after plunging, and then what you are giving? You are giving motion in this particular direction. So, when you are moving at that time your tool will experience one radial load. Correct. So, at that time it will provide both the things. How it will provide, we will see it soon. Right. So, maximum speed a bearing will be able to achieve, that depends on many parameters. That is first thing, the type of bearing. So, which type of bearing you are using? Lubrication method, because if you are going with a very high speed, what is going to happen, that it will actually heat up this lubrication also, and when you are heating up at that time, its viscosity changes. Whatever lubrication method you are using, it is a oil base or some different type of other grease or kind, then it is a problem. Preloading is important, how tight you are holding it, how loosely you are holding the bolt in between these two, and which type of loadings are there. So, if it is a both the loads, it is a radial and axial load, then you have to actually find the which way you can actually control the speed, so that it will rotate within a permissible limit of the bearing. A benchmark is used by the DN number. So, mostly we talk about the DN number. DN number goes up to the tens of lakh also, 10 lakh, 20 lakhs also available. So, what is that mean? That it is actually D is the diameter, bore diameter of the bearing, and N is the RPM of this part. So, if you are talking higher the DN number, higher is the RPM. Right. So, this is the thing. So, it is higher the DN number, higher is the RPM. When you are going with a higher RPM, we know that we have to use a very small shaft, because shaft dimension also play important role. So, when you are talking about lakhs of, consider the 10 lakh DN number. So, at that time mostly this major part is the RPM here. So, if you are talking about 1 lakh RPM, and then what you can think about that, it is a 10 millimeter is the diameter. So, 10 millimeter diameter and the 1 lakh RPM, that means you can go with a 10 lakh DN numbers. In that way you can actually define this time. So, this is the mostly we talk about the DN number. What is the DN number? Higher is the DN number, more you are thinking about the higher speed of the spindle. So, what is the contact angle here? So, it is a nominal angle between the bolt to rest contact. So, where is the bolt to rest contact? So, this is the bolt to rest contact, correct. So, this is the bolt to rest contact line. So, wherever this contact is, you have to draw one line here. So, this is the line passing through the bolt to rest, and a plane through the bolt center. So, this is the bolt center perpendicular to the bearing axis. So, this is the this is the bolt center passing through that plane, and this is the axis, bearing axis, and this is the perpendicular line to both the things, correct. So, nominal angle between the bolt to rest contact line and a plane through the bolt center. So, this is the plane through the bolt center. So, it is crossing here at this location and perpendicular to the bearing axis. So, this is the bearing axis perpendicular to the bearing axis. So, this particular angle is called alpha. Right. So, contact angle determines the ratio of the axial to the radial loading possible, with a radial loading being the primary benefit here. Because here what is going to happen when you increase the RPM, what is going to happen, and we are talking when it is under operation, right, you are doing milling operation or a drilling operation. When you do those things, at that time your board will actually experience many things. One is the radial loading and another one is the axial loading. So, now you have to decide at which particular angle you can actually get the benefit of both the things, that is axial loading and the radial loading. So, based on that you have to select the contact angle, which contact angle is better for a particular application. So, what are the typical contact angles? Typical contact angles are the 12 degree, 15 degree and 25 degree. So, what do you mean by the 12 degree? Suppose you consider this one is the 12 degree. Then when you are talking about 15 degree, that means it is increasing this part. Increasing this part, that means your contact area, if you increase, then your line of thing will actually pass through this way, and more you can go like this way, then at that time you can go with this particular part. But you are actually then compromising with one of these things. You are either increasing the axial loading or the increasing the radial loading. Both the things cannot be increased or decreased together. You have to this, because both these two things are actually inverse to each other. They both things will not go simultaneously. So, you have to first see that which particular application you are using this. It is a primarily it is for the drilling operation, better to go with the axial loading, because you are not worried about the radial loading there. Right. So, now these are the different ways we can think about those part. So, now this particular application will tell you that how we can select this particular bearing. So, let me continue this topic in the next class. We will see that what are the different types of the contact angle will create a problem for the different type of loading. Thank you very much.